Hello tribe of fans and welcome. Today we are going to be discussing a peak of German engineering, which is my Cube Fritzz 180 frame. And unfortunately, after 1.5 seasons of sporadic use, it has gotten a boo-boo. And I'm not kidding, they are even gloating about it being designed and engineered in Bavaria, and last I heard, Bavaria is a part of Germany. The core reason why I'm looking at this frame in such a vulnerable state is that I am reconfiguring this bike to be more about urban freeriding, or at least that's what I think I'm doing, because I'm fairly sure this old corpse isn't really capable of doing the cool stuff. Anyhow. What I'm going to be doing to the frame today is that I'm going to be placing a new chainstay protector. I intend to install some riv nuts here in order to route the cables like a human being, and I need to fix the issue of the upper rocker pivot, or this pivot here. In my opinion, the main problem with this frame is that it suffers from a little bit of a bipolar personality disorder, because from something that has 63 degrees of a head-tube angle and 180 millimeters of travel, which is obtained from kind of a beefy 240mm shock, although I had to engineer my own ways to mount this one because the frame wasn't compatible. However, big shock, slack head-tube angle, you can perform some serious droppage on this frame now, don't you? However, you can't, because this frame has been built to a standard that is closer to an all-mountain or cross-country frames than a proper freeride frame. You can even see from these blurbs that all German brands do on their frames that this is a efficient trail control or trail motion rocker, or here on this rocker, trail motion, right? So you can see that the designer of the frame thought of it as a long travel all mountain frame with 180 millimeters of travel in the back and front and 63 degrees of a head-tube angle. You can see that there's a little bit of a split personality, right? And at this point you're gonna say that I've been using this frame incorrectly because I've been urban freeriding on it, and you wouldn't be correct, because first of all, I am not some pilgrim, I'm just a huge coward who rides downstairs if the number of stairs doesn't exceed 5 and consider that urban freeriding. Now, is it? Yeah, possibly is, but I am not hammering this hardware all that much, but that's not really the point, because I've been using my Kona ever since I've got it precisely for riding downstairs and hopping from curbs. The point is that I bought this frame, I armed it, and then I used it 5 times in my local mountains, and I think it was on a wall hanging since October last year up until August this year, and there was no issues from that time. Then I've been to a trail center twice, and when I'm actually arming it to be used as an urban freeride in my particular way, I noticed the problem with this main pivot here. Alright, this is the entire suspension disassembled. Let's go. Alright, this is the entire suspension disassembled. This is the seat stay, this is the rocker, this is the chainstay, this is the main triangle. As you can see, the bearing in the main pivot on the triangle has been crushed, or the upper pivot on the main triangle has been crushed. We'll get into that in a minute. Let's go through the design of all the pivots here. This is the chainstay pivot. It is a dual bearing design, so there are 2 bearings here and 2 bearings here, 4 bearings in total. The bearing unfortunately isn't a full complement, there's a retainer here. We're going to return to that in a minute. This part is held, where is my tube? Here it is. This part is held by a screw, which is a tube like this one, which goes all the way through. There are 2 shims on both sides, like this, to provide proper spacing on this, and on the other side of the suspension, this bolt goes through here and is being held by this screw. Actually, it's in the other direction. The bolt goes in this direction. Overall, the design itself is great. There's no issues with it. It's perfectly functional. I have no problems. But one thing I would like you to note is that the bearings on the chainstay, on the seat stay, sorry, I'm going to show it to you in a moment. The bearings here are absolutely tiny. This is the part where I told you that this frame is built like a cross-country or an all-mountain frame, but has for some reason 180 millimeters of travel. And yeah, efficient trail control. Yeah. Alright. The other issue I have with this one is there's not full complement. As I said, we're going to return to that in a moment. This is the main pivot of the suspension. The bearing is absolutely massive, no issues there on one side or the other. I haven't even popped the cap here, but I'm sure that's not a full complement bearing. But I'm going to check anyway when I see... oh, there's my knife. There's a knife, and I'm sure it's not going to be a full complement, but there is no reason for this to be a full complement. Nope, it's just a regular plain old bearing with a retainer. Alright, but it's so big that there's no issue here. And the design of the pivot is also very good, because there's this element which goes through here, and it is kind of tight fitting. Let's try on the other side. Alright, there you go. There's an element that goes through here, which rests against the frame, and it's the friction is keeping it immobile, essentially. There's a parts of sealant accident this frame had. Then this bolt here goes into the frame and holds everything together. And because I'm not going to be able to extract this, but I'm going to take another one. Oh, here it is. Because these two parts fit each other so tightly. Focus there. Fit each other so tightly, there is no movement here, so the issue that caused this is not going to be happening here. This is also very good design. This is the rocker. There are two pivots operating here. This is the main triangle pivot, this one, the one that failed, and this is the other pivot. Let us call it a rocker pivot. First of all, you can see that this is also a very tiny bearing. There's just one of those here, and you can see that the bearing here is not full complement, which is another problem with this particular design. Once again, it's built like a cross-country frame. Now the other problem with this pivot is that this is the bolt. No, this isn't the bolt. This is the bolt here. Now this bolt goes through here. There's a shim on the other side. There's a shim on the other side, and this bolts right into the seat stay, like this one. And the problem here is that we're going to be discussing this in a moment, but it's going to be a problem. This is the main attraction of the freak show. This is the upper front triangle pivot, the one that failed, and you can see that the bearing here is completely destroyed. And this is the part of the corpse. The other parts of the corpse are all over the floor of the workshop. When I was disassembling this, it simply fell to the floor. Anyhow, what happened here? There are four bearings here. There is an element inside in which this bolt is being attached to, but since the bearings they are completely destroyed, I don't want to use violence to get it into that element. Anyhow, there's an element inside which this bolt and the other one from the other side is bolting through. Now, as you can see, the bearings are traveling on this bolt just like they do on this pivot here. Now, this is the main problem of this design, because here's the failure mode, or at least what I think happened. Alright, this is the mock-up of the upper pivot assembly, but let us first establish something. If a bearing is rotating the outer race in this direction, then the third Newton's law tells us that the other race wants to rotate in the other direction. If you're not going to take this into account, you are going to find yourself in all kinds of trouble. In this particular case, as the suspension was working like this one, the forces which were being transferred by this bearing would cause it to rotate, and it would slowly start to wiggle the screw in, out, in, out, in, out, in, out, and at a certain point it would cause it to unscrew on from this side or from this side, because screws generally want to unscrew. Once this assembly got a little bit loose, the outer bearing, because it will start to sag, because this the weight of the bicycle will cause that, the outer bearing was overloaded, and since these bearings are tiny, these are 6800 types bearings, so what I found that their static load is approximately 83 kilograms. This bearing was overloaded, was continuously overloaded, and at a certain point it simply cracked and collapsed on itself. Now, why did this happen? Because Someone at Cube thought that you can run your bearings on the bolt that is holding them together. You shouldn't do this, and a few manufacturers of bicycles are already knowing that. You know what I'm talking about. On this frame, two pivots share this problem. This one and this one. Obviously, because this frame is built like a cross-country frame, all of these pivots are using very tiny bearings. And to make the matter even worse, none of the bearings on this frame are full complement. And here's the explanation why. A bearing like this one has an inner race and an upper race, and its ability to carry a load in whatever direction the bearing was designed is essentially completely dependent on the amount of balls inside and the size of these balls. Obviously, the bigger the bearing, the bigger the balls, the better contact of those balls with the upper and inner race or outer inner race, the more load they are able to carry. The thing about load-bearing capacity of a bearing is that it is different from when the bearing is stopped and when the bearing is actually rotating. As a rule of thumb, when the bearing is stopped, we are talking about a static load, and when the bearing is moving, we are talking about a dynamic load, and the static load is approximately half of the dynamic one. The thing is that the majority of bearings on the market and majority of bearings everywhere are meant to be rotating and not really be stopped. So we want them to be good at being rotated. And in order to do that, we need to keep the balls apart because we don't want them to be rotating like this one against each other when they are touching, because that would introduce friction, and at a certain point we simply grind the balls to, well, not being really round, and that's a problem for bearings everywhere. Point being, majority of bearings on the market have this retainer ring which keeps the balls apart. However, not all bearings are being continuously rotated. For example, if you want to take into account thermal expansion of something, you might want to place it on a bearing, and if that thing expands, the bearing simply rotates very slowly, essentially being stopped most of the time. Sometimes bearings are being used in this fashion. It's being rotated fore, aft, fore, aft, fore, aft. This is a situation of a bicycle suspension, and this is also a case where we are more interested in capacity to carry a load and less about its ability to being rotated most of the time, because let's face it, it's not going to be traveling all that much. The friction between the balls is going to be minimal. However, the load might be quite a bit high. And the problem with this frame, especially in the largest sizes, which we can estimate are going to be used by heaviest riders, is that none of the bearings in this frame are of the full complement type, the type you can see on the screen right now. This is an Enduro bearing I bought for the replacement of the frame, but this is what technically is called a full complement bearing. In the marking of the bearing, it would be signified by a letter V. So this is a 6800 RSV bearing. And because there are so many balls and the load carrying capacity of a bearing of any kind is dependent on the amount of balls inside and the size of them, size we are stuck with, so we can only change the amount of balls. Having twice the balls makes this bearing twice as capable of carrying a load. This type of bearing should be used all over this frame, maybe except for the main pivot, because this one is huge in comparison. You can see that they are using huge bearing here and really teeny tiny bearing all over the place. This type of bearing should be used everywhere. Moreover, the pivots here and here shouldn't have those bearings traveling on the bolt. There should be some sort of a separation between the bolt and the running surface of the bearing. There it's not there, so this motion of the bearing in both directions will cause this bolt to unscrew. You can even see the marking, how it worked itself out of there. Essentially, this frame is held on the amount of torque you can put on this pivot and on this pivot, and the amount of thread locker you are willing to put there. And in the light of that, another thing to note, considering that everything is held by a thread locker and the torque on these two pivots, well, using on the biggest sizes at least aluminum bolts everywhere, ones which you can't torque really hard because they are aluminum, they're going to strip, is kind of a suspect move. But I guess that Cube is using the same, or was using the same suspension elements, except for the front triangle on each side. I can kind of understand this. However, on at least on the 20 and 22 inch frames, which are the two biggest sizes which you can estimate are going to be used by the heaviest people, you should have used stainless steel or steel of some sort bolts, because you can torque them pretty well harder. They didn't, so you can kind of expect that this frame was bound to fail. Now, the repair I'm going to make is that I'm going to use my full complement bearings. I'm kind of regretting that I haven't bought more of them, just 4, because I thought I'm going to be replacing only these. However, I'm going to put 2 here, I'm going to put 2 here, I'm going to recycle these 2 and put them inside. I hope that's going to strengthen the main pivot sufficiently, and if it doesn't happen, I'm going to devise some sort of other way of fixing the issue, and then I'm going to put it together and see how it operates. If there's not going to be an issue, then there's no issue. If there is going to be an issue, I'm going to make a custom stainless steel axles for here and possibly somewhere else, although I don't think that's going to be necessary. And there you go. The frame has been fixed, and now I'm going to install it to a bicycle or build a bicycle on this frame out of parts I have in the other parts of the workshop, and I intend to ride this bike tomorrow to work. And on my way I'm going to ride every stairs I'm going to encounter, because reasons. So what are my final thoughts about all of this situation? Well, you see, I'm not blaming Cube, because, well, they are doing what they're doing to make a business. The problem is that this frame has been optimized for capitalism. What do I mean by this? You see, you, me, and just about everyone out there is a consumer, and our consumer goods are becoming more and more complicated each day. Do you know how many valves and other interesting things are in this shock? I have no idea. I just know that I'm going to be turning these things, and awesome is going to happen. Now the problem is that we don't know our consumer goods, we just have requirements, and unfortunately for quite a bit of bicycles the requirements are make it flashy, make it cool, and make it light. And this is precisely what Cube has tried to do, because, well, I don't know whether it's flashy, although they tried. They are, after all, a high quality or quality company. They're not making Walmart junk. They made it functional, it works more or less, and they made all the numbers match the requirements of the customer, in this particular case me. So it has a slack head-to angle, it has quite a bit of travel. In my case it also has a very long shock, which is very important to me, because I can use lower spring rates. Yeah, I think I have explained this. Never mind. Point being, we don't know the goods we're using, and there is this temptation for a manufacturer to either hire someone who doesn't have the perfect or hasn't have the proper engineering background. They just need something that is functional and cheap. In this particular case, in order to chase for something lightweight, Cube used this really silly alloy bolt arrangement of the main pivot, and this pivot, and I think this pivot. They use very tiny bearings because, well, most people aren't going to be having a problem with those, and they trust that you're going to be keeping an eye on all the bolts or giving your bike to a bike shop so they can service it. What manufacturers also know is that majority of bicycles don't get ridden all that much. In this particular case, if someone buys this bicycle, it is more often than not they are going to ride it 3, 4, 5 times a year. Then they are going to hang it on the wall or store it somewhere, and on the next season it's going to get serviced thoroughly at a qualified service and it's going to be ready for action. The service is going to tighten all the bolts and everything. So knowing that this is the particular, or this is the typical use case for this kind of bike, what Cube did is they optimized for weight, because weight sells. Engineering is kind of difficult to sell. And this is the situation I have found myself in, because, well, I'm servicing on my bike, but I'm just a human, so this is, after all, an operator error. I have allowed this to happen because I wasn't paying attention. Although, if the pivot was designed properly, everything would work fine. My point is that because we don't know how to judge engineering of something, because most of us aren't engineers in that particular field we are judging, then we are trusting the manufacturer, and since we are buying on a different criteria than we are using them quite often, in this particular case This frame usually, or these bikes are usually sold on the merit of weight, not necessarily engineering or serviceability, then the manufacturer of the particular good is going to cut corners on the engineering in order to make it more, well, sellable. Alright, enough ranting. I hope you enjoyed the video. I hope you're going to subscribe to the channel if you haven't already. I hope you're going to tell everyone in 1 mile radius around you to subscribe to the channel, even if they don't ride bicycles, and I hope to see you on the next one.